Hi, and welcome to DCO. My name is David Capetti, and in this video, I'll be sharing how to create this truss system that is based on a curve that then we create a subdivision and then sweep it around, then subdivide it into this wireframe truss system that can be applied to any curve. So let's move this around and show you some of the capabilities here. We can change the size or the radius of the overall truss system. Here we have by how many it's going to be subdividing it by, and typically 3 is the minimum. Here we have the subdivisions, so if 20 is too much, we can always change it to something like 10. Here we have only one subdivision in the U and the V, and that's so it creates just one segment. At the end, we extract the wireframe and create kind of this X design and plug it into both Subd Multipipe, but also the pipe structure here that we can use 2 different sizes. We can also then create an array of arcs. And so at any point, if I want to do that to all of these, then I can create that array and plug it into the input. So we can do it to all of those at once, and we can visualize it completely. So hopefully you find that interesting and are excited about learning Grasshopper. I go over a lot of techniques that are useful for many other designs and just to get into parametric design. So thank you for being here, and let's jump right in. The first thing we want to do is bring in a line segment that we can use to create our truss. What we'll do is we'll go here and bring in an arc, and that's what we'll use for our example here. And there's different ways to create an arc, but we'll be using the typical one where we have a plane input, a radius, and an angle. For the plane, we'll go here to X, Z, plane. The radius, I'll plug in a value. And now using this segment, there's another segment that I've created here that we can also use as an input, but we can hide that for now, because maybe we'll use that later. Here with this arc, we need to create a frame or a segment that is perpendicular to this line. So there's a component called perpendicular frame, which will create a frame at the beginning of this line segment. So I'll plug in this arc into the curve. And for parameter, it's going to ask us to create a curve domain. So what I'll do is I'll construct a point, and I'll use it here at the 0 coordinate. And I'll plug that point into the parameter. And so basically we can move this point, and I don't want to preview this one because it's previewing the point moving along the X, and we want to show it moving along the curve. And we can change the slider to be a max of 500, and we can change where that is located. So now that we have this perpendicular frame, we can use that to create a segment that is a polygon. There are different ways to do this. We can start with the circle, subdivide it with points and use that, or we can use the polygon component, which will create a polygon on this frame. We can change the radius, but we can also change the segment. So we'll go to 3 less than 8. This way we can create 3 to 8 subdivisions. And I'll go down to 3. And the radius is going to be the size. What we need to do now is take this segment and sweep it around that arc. So we'll go here to sweep 1. Sweep 1 is going to ask us to plug in a rail, a section, and it says miter. We won't use that one, but just keep in mind that we need to plug the correct ones into the correct one. So polygon is going to be the section, and the rail is going to be our arc. Now, one of the things I want to, a technique that I want to share is that if the idea for the script is going to be to be able to change it, any curve, and change it into a segment like this, then you need to keep in mind that we have this arc output going into 2 different inputs, and it's a lot cleaner to have one output here go into this one and one go into this one. This way we can change the arc, and this is why I have here, if I do show, I have a different arc segment here that I created using a spline or a NURBS curve. So here I'll bring in a curve component, allowing me to then select this. And I can go to this component, right click, and set one curve. Now I can use that as the input and see that it does also work, and it's maintaining all of the programming that I've kind of created here. So let's plug this into the original one and leave this as more of an option. We'll disable the preview on this. The next thing we'll do is we'll go here to our output, and let's take a look at our B-Wrap. So it says open B-Wrap. So we know that this B-Wrap consists of that hexagon, so there's 6 segments. Let's bring this down to the 3 segments. And let's take this B-Wrap and we need to subdivide it. So to do that, there are different ways. I'm going to show you one of the approaches that will kind of maintain the arc of it, or kind of the flow of that curve. So what we'll do is we'll go with one approach, and if there's a different approach that I feel like is better, I might switch into that one. But for now, we'll take this B-Wrap and we'll deconstruct it, basically taking and exploding it into their own separate faces. So we'll plug this into the B-Wrap input. Now the faces is what we're looking at. When I hover here, we have 3 different surfaces that we want to plug into an isotrim. Isotrim, every time we bring it in with divide, or at least I do, divide domain squared, so we can subdivide it in the U and V count. So now I'll plug in the faces both into the domain and the surface, and plug in the segments into the domain. As you can see, there's something funky going on, and that is because we have these faces coming out not grafted, and then these segments come out grafted. So we need to go here and graft the input. As you can see, we have way too many subdivisions. I'll disable the preview here. And now let's change the U and V count, because for this to work correctly, it's either in the U and the V we have to do 1, and then in the other way we can have as many as we want. So we'll go here to 5. Okay, so these are the ones that go across this way, perpendicular to the curve, and then these would be the ones that create the original. All right, so now we have 1 segment, and then we have 7 segments here, and now we can take this and create more subdivisions, because I think that's not enough. We'll go here to 100, and so those are the subdivisions that we can create along that arc. And the reason why it's looking kind of weird is because we're still previewing all of this that we don't technically need to. So what we're doing is we're subdividing it this way, but there are different ways that we can subdivide the inside. So I'm going to show you one technique, but there are different ways we can do this. We can just create a diagonal if we want to. So what we'll do is we'll first extract the wireframe of this, then we'll go in and add more detail. Because then that could be two different options. We can have it be a truss that's created just with straight segments that maybe are welded together or bolted together, but we could also have some that have either diagonals or X's that connect either to the middle, or we can figure that out. So what we can do is take this, use a join B-Wrap, basically joining it all together. This way we don't have redundant lines here. And that's a technique that I suggest when you're just trying to do wireframe designs. This way you don't have redundant lines. Now we see here that we have one open B-Wrap, which is fine. Now we want to go to B-Wrap edges. And extract all of the edges here. I'll disable the preview on everything. And now you'll see that we have created that system. Now it's created off of that base curve, so we can also include that base curve if we want to as our design. That's up to you, right? There are so many different ways that we can develop this, that this is going to be the most basic way that you can do it in a few steps here. So you can just use a base curve and then create some kind of structure that looks like it's fully developed. So now let's take this and we're going to not just extract that wireframe, but let's extract an X out of here. So what we'll do is we'll go to these surfaces before we joined it, and we're going to bring in an area component, giving us the midpoint of every single one of those panels. Now that we have the midpoint, we're going to go to Deconstruct B-Wrap, and we're going to basically deconstruct all of these faces. But now we'll actually take the output of the faces into the center for the centroid so we can get the center. And now we're going to take these vertices, which are these outer points, and plug them into the outside to the center. So we'll go here to Align Component and start with vertices as the start point and the centroid as the end point. Now if I disable the preview on all of this, now we have a bit more of a complex design just because it goes from the outside to the center, right? And let's play around with some of these and change the sliders so we can decrease it, because if you have diagonals, then you have more support. For this next portion, now that we have these two, let's plug those into a pipe component. This way we can see what it looks like when it has a bit of some structure to it. So let's go here to pipe. I'll plug those interior ones into the input and also the naked one. The naked ones are going to be the ones on the outside, and the interior ones will be the ones on the inside. We can have this with two different sizes, so we can say 1.5 for the outside, and change the caps here by right-clicking. We can go to round caps and now have a different size. So I'll copy this over and have these be the input for the inside ones and have them be a smaller size. So that's one way to kind of create it pretty straightforward with two different sizes. And the next way would be to use the Subd Multipipe. I have my own kind of method of using this one, but you can basically plug in all of your curves into the curve input. I'll disable the preview on this, and then I'll flatten the input for this one. It creates a really nice connection, a neat connection here. Now we can change the size, the strut size. I'll go 1.500. What happens is it starts making the segment large, but the connection small. I'll create a copy and then go to node size, and then be able to increase that, but then I have to decrease the size of the strut size. Either way, those two kind of work. And that kind of concludes the idea of the basics of how we can create this truss. Now, the cool thing is that we can take this arc and we can create an array of arcs here. So if I take this arc and go here to move, I'll take this arc, move it in the Y direction. So I'll go here to unit Y, and I'll plug in for the factor. I'll go here to series. The step is going to be 240. That's how much I want them to be spaced out by. The count, I only want 5. And start at 0 is fine. Now I can do a series of numbers starting at 0 and ending at 960, stepping by 240 with 5 different numbers. I'll plug that into the factor, and those unit vectors will go into here. Now, maybe the gap is a little bit too big, or maybe this is just a little bit too small. Now let's move around and let's play around with some of these parameters, because what we can do now is with all of these curves, we can plug those into here. What we need to do is graft each output, and now it's going to create that truss system for all of those. So this is why I feel like Grasshopper is so valuable and so important, is because it allows us to program a design, let's say this type of structure, and now we can apply it to any curve and change how many subdivisions. So if this is 3, we're going to now go to 4. Now it does have to calculate all of those movements, so it does take a little bit of time, but how cool is that? And this is just the basics of creating this truss system without any fancy other things that we could do. We can take these segments around here and then twist them and start turning them around, creating more of a dynamic design for each segment. But what we'll do now is go here to strut size. When we have too many, it does make it a little bit harder, especially when we have these many subdivisions. So we'll go to 3. And now we'll go here to cool. So we've done this mostly parametric here. What I will be doing now is let's go here in Rhino and let's create a set of arcs that are more dynamic. So I'll just create a basic arc here, starting here, ending here, direction this way. Then under the top view, I'll create copy, and I'll create more than one copy. So I'll do copy, turn on project, so we don't move it up or down. Now in here, I'm going to select it, go to cage edit, bounding box, and I'll do the default for world. I'll do spacebar, spacebar until I get the points. Now I'll take this, move this over. Do that again, like this, page edit. One more time. Select these, cage, edit, bounding box, enter, enter, enter. And I'll select these, move them over. I'll select the top ones, move them up. So now we have all of these different curves. I'll go in here into Grasshopper and go to select, set multiple curves. Now let's try it out. Let's try to see if those inputs work out with our design. And they won't until we graft it. So let's go here to graft. And it will create those segments right on that. So if you had, let's say, a design of something like this that was lofted, you can take this and now offset this, flip the direction, and then create a gap. This way we'll do solid, no. And so I can kind of keep offsetting it until I get to the outside. And this is just a rough sketch, but that's how cool and that's how useful it can be to also combine Grasshopper with Rhino, because you can create a lot of more dynamic and quick changes if you're modeling, but you do miss out on some of the capabilities that you can do here inside of Grasshopper. Hopefully that was useful. This is a straightforward tutorial that can show you a lot of techniques that can be used anywhere else. If you enjoyed the content, make sure to give it a like and subscribe for future videos. I make videos like this every week where I share the process for creating architectural and parametric designs using Grasshopper for Rhino. And if you want to get a hold of the script that I made for this video, check out my website capettidavid.com. There, when you become a script vault member, you'll have access to the video script and much more. I also have a script store with scripts that are ready to go and you can also contact me there. And if you're brand new and have never used Grasshopper before, I would suggest checking out the self-paced workshop that I have on my website. Thank you very much for being here, and I hope to see you next time. So in this portion, I actually want to keep working on this a little bit more and go back to our original arc. And then we can basically disable the preview here. And most of this. Just basically disable preview here and even disable it, right? So it doesn't compute it. We don't even need this one yet. Okay. And I'll go back to this one. I am now going to use this B-Wrap and just deconstruct it, or go to B-Wrap edges. And now I'll actually copy over one of these. I'll enable them and plug both of these in and turn the preview on. So the option that I'm creating here is going to be with outer frames that have a specific size. And then here we'll just do an array of these segments here, them being smaller. So how can we figure that out? Well, we need to go back to I'll disable this one. We'll go back to our arc, which is this one. And then we have our segment, which is this one. So what we'll do is we'll create a pipe segment here. So we'll take this, copy it over, plug in the polygon into the pipe, and let's disable the preview on this so we can just take a look at the segment. What I'm doing here is just decreasing it. And now we'll do array curve, or curve array. We'll array this pipe or this geometry along the arc. My apologies on the background sound. So let's go here and plug this arc into the curve. Now here we can pick how many copies it creates. So we'll go here to count. And now I'll preview this pipe. So this is another cool way that we can develop this. Change the size of the outside one here. And then here's the size, or the copies of the ones on the inside. And then with this one, change the size. What I'm seeing is that at the end we can do a Boolean union, but I don't recommend it because I think it will cause some issues. So for now we'll leave it like this. But I just wanted to show you some even more options as to how you can do something like this, or how you can develop a structure like this. So I'll leave this here on the side and I'll group it. So this will be technically a different option than this one. Now for this last extra content, I do want to show how to not just create this extrusion or this one segment like this, I do want to show you how to make it more dynamic. So for that, we'll take this, we'll disable it, we'll even disable the preview on this because we don't need it, and same with some of this. So we'll use the same segment and we'll use the same arc here. Now what we want to do here is create a perpendicular frame, but a set of perpendicular frames. So we'll use the arc, and rather than just doing one, we'll do this, we'll copy it over. And so I'll plug in the frames into the plane. So we basically created a set of copies of this shape. Now what I do want to make sure is that I only do, let's say 3 for now. So the radius is going to be 42. And then if I plug in a different radius, it's going to do a different radius for the next one. And then if I plug in the next radius, so making 3 different sliders, plugging them in progressively, 1 for each. So just make sure that you don't change the number of counts here. Now with that, we can loft together those lines. And we can have the middle one be the same. So we'll do, let's say 42 here. And then 42 here. Or make it larger, right? And so with this one, we can plug that into this one, into this design that we have here. So this is just creating that base surface that we can then develop. So sorry about the background sound, but what I'll do is I'll take this and I'll copy it over. So all of this, I'll copy it up. And then I'll plug in this loft into the B-Wrap input. And now I will enable all of this. And then I will also preview this one at the end. So the cool thing is that we know that we needed that base loft because it's the same thing as this. And now we basically subdivided it and created that same subdivision with a different base surface. So let's go back here and take a look at how this was created. Let's see how we can also change it here on the fly and have it be dynamic like this. So remember, we can't change that, but we can change, or we could change it, but we have to add more inputs. We'll go here to 5. You'll see how that works. So I hope you enjoyed that extra content. I will also have this on the script vault portion. If you have any questions, check out my website and send me a message there. I can answer any question. And thank you once again for being here.